An interesting question came up in class recently where we were looking at some of the properties of logarithms, and one particular property was that if you took a base b and you raised it to an index that involves the logarithm base b of x, the b and the log base b disappear and you end up just with x. In other words, this x here just ends up on its own. So there's some cancellation or something like that going on. Okay, one operation basically undoes the other. Why is this? Why does this work? And just before we do that, why don't we try one? The log button on your calculator is a log base 10. Okay, so if we typed in 10 to the power of, say, log, and that's log base 10, by the way, of, say, I don't know, 5,000. Do we get 5,000? And we do. Okay, so somehow the base and the log of that same base somehow cancel out and they disappear. Let's see why this works. Okay, so it's basically a proof. What we're going to do is let's write it as b log base b of x equal to n. And what we're going to do is we're going to try and show that n in fact equals x. So if we can show that, then we've proven it. Okay, let's write this now in logarithm form. Okay, so remember that this is a power. All right, so b to the power of something equals n. How would we write this or rearrange it so that we write it in logarithm form? Just to make it a little bit easier, what we're going to do is we're going to say let a equal log base b of x. So b to the power of a is equal to n. Okay. That's a lot easier to work with. Let's write this now in logarithm form. Okay, so in other words, log base b of n is equal to a. Okay, happy with that? But we know what a is. Okay, so a is log base b of x. Log base b of x must equal log base b of n. So if the log of the same base of x equals log of base b and n, what can you say then about x and n? Okay, it's the same log. Okay, that means then that the x and the n must be identical. Okay, x must equal n. So therefore, b to the log b of x equals n, which equals x. Okay, so b log b of x is equal to x.